In this In this tutorial, we will learn how to use Praat for doing basic audio annotation and form extraction. To start, you need to install Praat. It's available for a variety of different platforms: Macintosh, Windows, Linux, FreeBSD, SGI, Solaris, HPUX, in case you're really old school, and you can download the source code. And compile it yourself if you're so inclined. Sometimes that might be useful to do on Linux because there's some compile time options that can affect how it works with the audio system on your particular device. Although for most modern Linux distributions, then it should work fine out of the box. So after you've installed Praat, then can run it. And you get two windows. One is the Praat Objects window, and one is the Praat Picture window. So the Objects window contains all of the objects, which could be audio files, formants, spectra, anything that is the product of making a command. Any kind of data object shows up in this objects window, and you can change the names of objects and do various things with them. There are context menus that will appear in the objects window depending on the type of the object. It allows you to perform various operations on it. So to start off, let's record a sound object. So we'll go to record mono sound here. And we'll just hit the record button. The defaults are actually sensible for our purposes. For some use cases, you might want to have a higher sampling frequency here for the recording. You'd want a mono rather than stereo recording for most uses in speech analysis, although not necessarily in speech technologies. And we'll use the built-in microphone. Although when you're doing your own project, you should consider using an external microphone. And the reason for this is simple. The closer the microphone is to your mouth, the higher the signal to noise ratio is. And so the less noisy your recording will be. And to some extent, the better results you'll get. However, we've observed fine results just using the built-in microphone in many computers. So we'll go and hit record and be sure not to start talking until it indicates that it's recording, because there's a pause between when you hit the button and when it actually starts recording. Now I'm going to record carrier words for American English vowels. So I'll say beat, bit, bait, bet, bat, boot, book, boat, bought, bought, but, but. Beat, bit, bait, bet, bat, boot, book, boat, bought, bought, but. Then we can just hit save to list. Close the window, and you note that in the objects window we now have a sounds object. We can rename that to be whatever we like. We'll just call it words. And it gives us these context menus. So we can do things like play the sound. Beat, bit, bait, bet, bat, boot, book, boat, bought, bought, but. You can draw the sound in some way. we can query various things about the sound, like the length and the max and min amplitude. We can modify the sound by doing things like reversing it or subtracting the mean or multiplying by a particular window. And we can annotate the sound, which is what we will do. So what this toTextGrid option does is it takes the sound object and creates a TextGrid object, which is an annotation object that's of the same length as the sound, the same duration in terms of numbers of sentences. So if we click that, then it gives us this option and very stupid defaults. What we want as a tier, we probably want just one, it's called a tier. It's like a parallel level in a lattice. And we'll call it vowel. And we have a choice when we're creating a text grid about whether we want to annotate intervals or whether we want to annotate points. And because vowels exist over time, then in this case we want to annotate intervals. So none of these tiers will be point tiers. So we'll leave this box empty. And we'll hit OK. So now we have a text grid object in the menu. So let's back up a little bit and see what it looks like, what the sound object looks like, and then we'll see what it looks like in conjunction with this text grid. So if we select the sound object, we can go to View and Edit, and we get something like this. So at the top we have a waveform, and at the bottom we have a spectrogram, except we haven't zoomed in far enough to actually see the spectrogram because it can't, for memory reasons, it doesn't render the whole spectrogram when you have a long sound. So if we zoom in by highlighting a portion and then going View, Zoom to Selection, which we can also do with Command 1 or N or Control N, then we see a spectrogram here, and we see the waveform here. And if we hit this button here, then it plays the interval that's in the window. If we want to play the whole sound, we hit this total duration button here. Beat, bit, bait, bet, bat, boot, book, boat, bought, bought, but. Okay, then we can zoom back out to the whole sound, and just as when we're zoomed to the whole sound, we have three different options in terms of playing. We can play the total duration, the part that is visible, or the part that is selected. And so if we just play the part that's selected here, bat, we get bat. So if we zoom back in, we can also use these buttons here. Zoom to selection. Then we can see that this part of the recording is a vowel. Actually, the vowel extends back to about here or a little farther. You can tell it's a vowel for two reasons. First, in the waveform, then it's relatively high in amplitude, and the sound is periodic. So this means that you have regular intervals between the peaks. Those correspond to the fundamental frequency, or the rate at which the vocal folds are vibrating. And you can see this also in the spectrogram with these striations that correspond to glottal pulses, to the same thing as these peaks and valleys in the waveform. So it's high amplitude and periodic. Ba. And if we play it, we can hear, oh, that's the vowel. And this is the T. And here's the B. Hard to hear at all in isolation. So that's what the view and edit window for, or the editor for the sound object looks like. Now let's take and highlight both the sound object and the text grid object by shift clicking and select view and edit. So here we get a window that's very similar. The difference being that instead of just having the waveform here and the spectrogram here, we also have this tier, this space here. And this is where the annotations will go. So what we're going to do is zoom to this first token. By the way, this blue plot here is the pitch, and it's only present when the algorithm can detect F0. So it's often helpful for finding vowels because vowels have a clear F0, a well-defined F0, whereas noise, like the release of this T, does not. It's hard to find a consistent fundamental frequency that you could use to define the pitch of that sound. So what we're going to do is find the beginning of the vowel here. So that's going to be the first cycle is going to be right about here. Beat, 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 beat. We can go a little farther than that because we got a little bit of the B. Beat, beat, beat. Now you'll notice that by the B, all three of the formants are depressed. And you'll remember when we talked about the perturbation theory that this is an effect on all of the formants by a labial closure, which is the closure of the lips, which is what you're getting with the B. Anyway, so we'll find the beginning of the vowel. We'll click this little circle here, and we'll type the vowel. In this case, it's an I, because we're going to use the IPA labels for the vowels. And then we're going to find the end of the vowel. Now, technically, the end of the vowel is somewhere here. So if we play beat, beat, this portion, then we get just the initial consonant in the vowel. Then we'll click this little circle again, and that gives us the end boundary to the interval. Beat, beat. So if we select this interval, beat, 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 then we get just E. Beat. It sounds a little bit like beat because, again, of the depressed formants. So in the homework, we'll use a script that takes only the formant values from the midpoint. So it would take them from about here. So it doesn't matter so much that we have this co-articulation on either side. But if you were using a different kind of script or doing a different kind of analysis where the dynamism of the formants mattered more, then you might want to set the boundaries farther in to the center of the vowel to avoid effects of co-articulation. So we're going to do the same thing with the other vowels. Bit, So I'm using an input method for IPA that you may want to use as well, that's produced by the Summer Institute of Linguistics, or SIL. It's available for free, and there are similar input methods for Windows and Linux. We'll actually constrain these a bit more. We'll get better results.
Back. Boot.
You'll note that the
Book.
text occurs both in the tier and in this editor window up here, editor box, text entry box. And this is, if you want to position the cursor within the text that's in an interval, then you would do it in the box up here. It just displays down here.
Boat. Bought. Bought. But.
Sometimes I don't remember what the keystroke is for a particular IPA symbol, so I have to hunt around.
But.
Okay, then if we zoom out, then we see that we have in this tier all of the vowels annotated, all of the vowels for each token annotated. What we can do then is download the script from Piazza that we'll use to analyze these. Which looks like this. As I've mentioned before, Praat has the worst scripting language I've ever seen. It's very much oriented towards the structure of the GUI, so everything is constrained in that way instead of in a way that would be more natural for programming things, but it works. So here we have the script. What we're going to want to do is take this file and this text grids, and we're going to want to save them. Save the sound as a WAV file. We'll put them in the desktop in a folder called vowels. We'll save it as words.wav. We'll select the text grid file and save it as a text file in the same directory. Then we'll go to the script. By the way, if you wanted to open the script instead of opening it directly from the web browser, you could save it and you could go to open and read from file, and it would open the script in the script editor window. So now we've saved the file, we can run the script on it. So we go to run, and then we have to specify the location where the sound and text grid files are saved. It's going to look relative to where the script is saved. So we're going to have to give an absolute path where we'll say users Mortensen desktop vowels, and there's one tier. The first tier should be used for analysis. We'll save the results to results.txt, which will appear in the same directory as the script, in this case the downloads directory. And then we can set various parameters. Because I'm not an adult female and I have a longer vocal tract, my maximum formant will be lower. So we want to set this down to about 5,000. Otherwise, we could have a Laurel Yanni situation. The other parameters we can probably leave the same. Sometimes we may not have to change the number of formants in order to get things just right. You may want to play with that, but first play with the maximum formant. So this could be anywhere from 4,500 to 6,000, depending on the properties of your vocal tract. Then we press OK. And what this does is plots each of these vowels based on its formants. Now we see that things end up largely where we expect them to be. The exception is that O comes out to be rather high. That's probably an error, and so does O. And if we had more data, we might not see that. But if we look here in results.txt, then we have each of the formant values. We've got the label on the interval, and then F1 and F2. We could easily expand the script so it also did F3, but we're not doing that for the purposes of this assignment. So that concludes this demo. You'll be doing the same thing basically in class, just to make sure that you know how to do everything. And you'll apply then this to the homework with some additional twists.